Today we want to look at how you can convert a simple linear inequality into a diagram on a number line and also into interval notation. We have here 3 examples of linear inequalities. Let's start with the first one. X is greater than 2. This case is saying that all the x values that are greater than 2 need to be represented, first of all, on the number line. So, to draw a picture of this inequality, put down a number line, remembering that it represents all the real numbers, x. And now what we want to do is only shade in the x values that are greater than 2. So here is 0. Always put that on your number line as a placeholder. And then 2 would be approximately here, is the other key value in the inequality. We want to represent all the values that are greater than 2. So we're looking at values over here on the number line. In order to show that in picture form, we're going to shade that section of the number line. Since we want all the values greater than 2, that means it would actually go on forever to the right. So you also want to shade the arrow. The question is, what do you do right at the value 2? And in order to indicate that we want values that are strictly greater than 2, but, as it says right here, greater than 2 does not say or equal to. So that means we don't want to include 2. It would be like starting at 2.1? No. 2.01? No. 2.000001. We want to get infinitely close to 2, but just not include 2. In order to indicate that with a symbol, we use a parentheses at 2. And whenever you put a parentheses on the number line, you always face it towards the shaded area. That's the picture of x is greater than 2 on a number line. We also want to be able to write it in interval notation. And in order to do that, we're going to mimic the picture quite closely. So always start at the leftmost end of the shaded section and write down what is happening right there. It is shaded all the way down to the value of 2. So put a 2. Then for the shaded section in the center, I think of that as like being, in interval notation, a comma. And then indicate where the shading stops at the right, which since it never stops, we say that it goes to infinity. And then you're going to wrap your interval notation with parentheses or brackets, just like on the number line. So at 2 we put a parentheses, since that's what we had on the number line. And at infinity, we have to have also a parentheses. Anytime you have infinity in the interval notation, it always gets parentheses. Let's try the second example and see how it works as well. So in this case, now we have x's values that are less than or equal to 2. So when we put that on the number line, we would be wanting to shade values to the left of 2. Values that are less than or equal to 2 would be to the left. Shade that section in, including the arrow to say to infinity, actually negative infinity. And then at 2, we want to include it this time because it says or equals to 2. So that means that the symbol we're going to use is a bracket. Brackets always go with less than or equal to and greater than or equal to. And they face towards the shaded region. So this time it's facing left. In interval notation, what would this look like? Like before, you want to start at the left end and work your way to the right. The order matters when you're converting to interval notation, left to right, left to right. So the leftmost value on this shaded interval is actually negative infinity, since it shades forever, a comma for the central section, and it stops at 2. Then we would want to add in a parentheses or a bracket. Remember, infinity always gets parentheses. And then in this case, since the 2 had a bracket, that's what the interval notation gets as well. Let's look at one more example. In this example, it's called a compound inequality because x is in the middle. We would read it as negative 3 is less than x, and x is less than or equal to 2. Or if you want to picture it like this, x is the values that are between -3 and 2. Not including -3 because there's no or equals to, but including 2 because there is. On the number line, that would look like this. -3 is key, always put on 0. 2 is key. And then what we would do for shading is we would want to shade all the values between them, like this. So those are all the x values represented in that inequality. Choosing parentheses or brackets, it will mimic based on if it has less than or equal to. Since this one has a less than, we would use parentheses, face towards the shading. On the other end, a bracket facing towards the shaded section. There's your number line diagram. You're also probably going to want to know how to put that in interval notation. So remember, work from left to right. So the left end of the shaded section is a -3, which means write down -3, a comma to represent the shaded section, and then it stops at 2, a parentheses on -3, and a bracket on the 2. Ta-da, you've got your interval notation. That covers most of the regular types of cases you might run into. Just wanted to also mention as a side note that sometimes you want to represent all the real numbers in a solution to a problem. In that case, if you get that given to you, one way you can represent it on a number line would be to just shade the entire thing. But how would that look like in interval notation? Follows the same concepts as before. Starting at the left end of the shading, which is over here, we have shading to -infinity, comma for all of the central parts, and then at the far right, we end at +infinity. And remembering that infinity always gets parentheses. Hope that helps. Good luck, and talk to you next time.
Made with Doodlecast Pro.